welcome back. I'm Rakesh Naik. Today we are going to learn about Prim's algorithm to find minimal spanning tree, which is an application of greedy algorithm. Before we start, a small request. If you are watching this video for the first time in this channel, kindly press the subscribe button and along with that the bell icon so that you will get all the notifications from this channel. So let us start. Before we start talking about minimal spanning tree, let us try to understand what is a spanning tree. So if a graph is given with VE, V is the number of vertices and E is the number of edges, then a spanning tree T is a subgraph of G which contains all the vertices of G. So we'll say T is a spanning tree. For example, let us say here is a graph given to me and the dotted yellow line represents a spanning tree. Similarly, one more spanning tree can be a dotted green lines. So there can be many number of spanning tree which are possible in a graph. So let us see what are the application, why we are learning minimum spanning tree, what are the application of minimal spanning tree. Basically minimum spanning tree is used for routing algorithm, network algorithm, minimax process control, cluster analysis, and there are many more applications for minimum cost spanning tree. So basically what are the objective we are going to have? Let us see the objective. Suppose each of the edge of the graph given is associated with a non-negative value. Let it be the cost, weight or length. So such kind of graph we'll say is a weighted graph. And we are going to take this weighted graph to find the minimal spanning tree. So to find minimal spanning tree we are having two methods. One is a Prim's algorithm and another is a Kruskal algorithm. And today we are going to learn about Prim's algorithm. So the basic difference between Prim's and Kruskal algorithm is that in Kruskal algorithm it is not necessary to choose a vertex which is adjacent to the already selected vertices, but under Prim's algorithm we have to choose a vertex which are already selected, and this vertex is supposed to be adjacent to the already selected vertices. So these are the basic difference between Kruskal's and Prim's algorithm. So what we are going to do in Prim's algorithm? In this method we are going to find the minimum search tree which grows naturally, and we'll start with the arbitrary root node, and at each stage we are going to add a new branch or new edge to the tree which is already being constructed, choosing each time the edge cost minimum increase in the sum of the cost included so far, and we'll stop it when all the nodes are reached. So the basic steps we are going to follow: let V is the set of node vertices and E is the number of edges in the tree, and we will initialize V as a single arbitrary vertex and T will make it 5, and we are going to choose the smallest possible edges UV, so that one end of the edge U is in already selected vertices and another end is on the other part of the graph. And this edge we are going to include if it is the smallest value, and we'll continue this until n-1 number of edges are selected. Why n-1 number of edges? Because in a tree with n vertices there are supposed to be n-1 number of edges. So let us try to apply Prim's algorithm for this particular graph. So initially we are taking, there is only one connected component and it is having 1, and we are starting with 1. So in the first step, the smallest value associated with 1 is the edge having value 1. So it is in between vertices 1 and 2. So 1, 2 vertex is included into it. Then the second step, along with 1 and 2, the other smallest edge is 2. That is between 2 and 3. So 2 and 3 is included. So in the set of vertices, I am having 1, 2 and 3. So in the next stage, I am having vertex 1, 2 and 3 available to me. So I am having 1, 4, 2, 4, 2, 5, 3, 5 and 3, 6. Out of these the smallest value possible is 4. So I am going to choose the edge 1, 4 and the number of vertices are 1, 2, 3 and 4. So now I am having 4 vertices, 4, 1, 2 and 3. Now I am going to choose the next smallest value which are associated with these vertices and which is not forming a cycle for me. So the next smallest edge is 3. So the set of vertices are 1, 2, 3, 4 and 5. So along with that, the next smallest value possible is 4. to this existing tree, the next possible smallest value that I can add is vertex 4, 7 with value 4. So the vertices are 1, 2, 3, 4, 5 and 7. And to this existing vertices, the next vertex that I can add is vertex 7, 6, which is having value 3. So I reached at a position where all the vertices are covered and it doesn't contain any cycle. It contains all the vertices, so it is a spanning tree. As I have taken the minimal value every time, so it is a minimal spanning tree. So according to Prim's algorithm, if this is the graph given, I got the minimal spanning to be this one. This is the Prim's algorithm using greedy technique. If I'll apply this algorithm, I can very well get my application. I can get the value, and if I'll apply this, I'll get the result I desired. And let us see the complexity of the Prim's algorithm. As I'm trying to find the least value of each age, so obviously the order will be order of E. But there are two for loops there we are including in that, so the order becomes big O of n square. So the Prim's algorithm's time complexity is big O of n square. Thank you for watching this video till the end. Keep watching, keep learning. If you like this video, kindly give a thumbs up and kindly share with your friends. I'll be back with one more video. Keep watching. Thank you.